Hello, I'm Jared Skeens and welcome to Quick Fix. Today we want to look at our IGCSE winter of 2018, the October-November series. And we want to look through this paper 42. I've already done it so that we can go through it a little more quickly. And I want to focus on talking about the mental things while you can look at the details, and you can pause the video whenever you want to catch the details of how it works. So let's get started. Number one here, we have this exchange rate. And so we start with dollars and then it's being converted to euros. So the key here is lining up your units. You have $1,962. We want to get rid of dollars, so we put it on the bottom of our conversion factor. We put euros on top, and it's a simple division of 1,962 divided by 1.635 to get the 1,200 euros. Then we move on, and it says that the family spends 15% of the dollars. So we're back to dollars, and if you spend 15%, then that means you lose 15% from the total. So the total's 100% minus the 15%. Means you have 85% that they have left. So 85% of the 1,962 is the $1,667.70. Then we move over to part III, and we have these two waterfalls with a ratio of 5:1, the Humboldt Falls and the Bridal Veil Falls. And the Humboldt Falls are 220 meters higher than the Bridal Falls. So our Bridal Falls are going to be the X, and the Humboldt Falls are 220 meters higher, so that's X plus 220, and you put it in the same order as what you see at Humboldt to Bridal, in the same order as your ratio 5:1. So that creates a proportion, two ratios, X plus 220 over X equals the other ratio of 5:1. Then you just cross multiply, and from here it's simple algebra, solving it for X, which you get 55. Now remember, X represents the Bridal Falls. It was the X. So what this is asking for is the Humboldt Falls. So we got to take our answer of 55 and add it to the 220 because we're looking for the Humboldt Falls, not the Bridal Falls. So we end up with 275 as the answer. So make sure you don't stop at the 55. Make sure you're paying attention to what the X represents and what the question is actually asking for. So as we go on to part B, we have another falls. Brown Falls has a rate of 3,680 liters per second. After the rain, it increases to 9,752 liters per second. Calculate the percentage increase. Well, the increase is the final minus the initial, what it was after the rain minus what it was before the rain. And then since it's a percentage, you divide it by the original, which is the 3,680. So the 9,752 minus 3,680 is the difference, divided by the 3,680, which was the starting value, gives us 1.65 as a percent is 165%. Then we move on to another waterfall, the Sutherland Falls, which after the rain is 74,240 liters per second. This is an increase of 45%. Whenever you see increase or decrease, it is from an original amount, which would be 100%. So 100% plus the 45% as decimals gives us 1.45. That is 1.45 of the original amount before the rain, which would be our X. So 1.45, the increase times the X is what gives us the increased rate of 74,240. Divide by the 1.45. And so the amount before the rain is the 51,200. So make sure that you're paying attention, especially to this increase, decrease of a percentage that you add or subtract it from 1. Moving down, sorry it's a little blurry here towards the top, but I think you can still see it. This is just a simple solving. Orders of operations. Here you have a parenthesis, so you distribute the multiplication through the parenthesis to get the 9 minus 12x. Add the 12x to the other side. I like to prioritize my x and make it positive. So then move the 30 to the other side, making a negative 21. Divide by the 14, and you end up with a negative 21 over 14, which is simplified by dividing top and bottom by 7. And then you get a negative 3/2 as your simplified answer. You can leave it as an improper fraction, or not an improper fraction is no problem for higher math. So a negative 3/2, if you put a negative 1.5, that's okay as well. Then we have factoring. Remember, factoring is division. So with the coefficients, the basic math, what number divides out of 12 and 18 is 6. And then with the letters, you're following exponent rules. And exponent rules with division means you're subtracting the exponents. So what number divides out of 12 and 18? The largest number that divides is 6. And then how many variables can you subtract out? We have 1a and 3 a's, or a to the 1 and a to the 3rd power. So we can take one of those out. We have b to the 3rd and a to the 2nd, so we can take 2 of those out. We're subtracting those out, the exponents. So what that leaves us left, 12 divided by 6 is 2. 1a minus 1a, there's no a's left. 3b's minus 2b's leaves 1b left. 18 divided by 6 is 3. 3a's minus 1a, it leaves 2a's. 2b's minus 2b's, they're all gone. And so this is our final factored form. Now we move on to some exponent rules here. This is multiplication. So the basic math, which is the coefficient, you just multiply like in basic math. 2 times 5 is 10. With the variable and exponent, your exponent rule with multiplication is to add exponents. So 3 plus 2 is 5, and 2 plus 7 is 9 for the A and C. Then now we have an exponent raised to an exponent. And remember, exponents distribute to both multiplication and division. Exponents do not distribute to add and subtract, but there's no addition or subtraction in the parentheses. It's all multiplication and division. So this 3/4 needs to distribute to each, the number and each variable. So when it distributes to the 16, remember that the bottom part of the fraction for an exponent fraction is a root. So that's the 4th root of 16. The 4th root of 16 is 2. Then cubed, the top part of the fraction is exponent. So 2 cubed is 8. And then when it comes to your variable and exponent rules, an exponent raised to an exponent, you multiply. So 8 times 3/4 is 6, and 12 times 3/4 is 9. So you have the simplified version there. Now we get into direct and inverse variation. This one is inversely proportional, which gives you a y equals k over the x. If it's directly proportional, it's y equals k times x. So with inverse, they have to say the word inverse. If it's directly proportional, they don't always say the word directly. So if there's no other word there, just proportional, it's automatically direct variation, y equals k times x. K is your proportionality constant. Don't forget to put that. A lot of people forget the proportionality constant. You have to supply it. You don't see it in the problem. So since this is inversely, it's y equals k divided by x. Now the x is going to be expanded. It says the square of x, and that's a plus. It's a little blurry. From here it looks like a minus, but it actually is a plus. So sorry about the blurriness there. It is a plus. And notice it says the square. Be very careful. A lot of students get confused between square and square root. So this is the square. It's on the outside, x plus 2 squared. If it says square root, then obviously you put it inside a radical. So read it carefully because a lot of students confuse square and square roots. So once you've set it up in the pattern, inversely and expanding your x to the square of x plus 2, then this first set of numbers you plug in the 3 and the 2 so that you can find the value of k. This is just simple algebra here. 3 plus 2 is 5. 5 squared is 25. Multiply the 25 to the other side to get 50. 50 is your proportionality constant. So now that you have that, you set up your problem again with the k put in, and now it only gives you one number. X equals 8, and you have to find the y. So plug in the x. 8 plus 2 is 10. 10 squared is 100, and 50 divided by 100 is 1/2. That's your value for y, and you get 1/2. If you train your mind to go through this, I know there's other ways of doing it. Some people try to do ratios and make it go faster, but I find a lot of students make mistakes because they mishandle the proportionality constant. And if you structure your thinking in this pattern, you'll get it right every time as long as you read the question carefully. So moving on, here we have simple fractions being added or subtracted together. This is just finding common denominators, and yet a lot of students struggle with this when you shouldn't. Simple common denominator, you have a factor of 2 and you have a factor of x minus 2. This one has the x minus 2, it needs the 2. So multiply top and bottom by 2. This one has the 2, it needs the x minus 2. So multiply top and bottom by x minus 2. So you have 2 times 5 is 10. Actually, let's look at the bottom first. The bottom now will have a common denominator of 2 and the x minus 2. So both of them now have the 2 and x minus 2. So since they have a common denominator, we can now join the numerator. Okay, so in the numerator, you have 2 times 5 is 10. Now this is where a lot of students make mistakes. This minus sign does not just go to the x squared. This minus sign is between the fractions. It is not in the numerator. So because it's between the fractions, this minus sign goes to everything that follows. So it's important to put your x, this is actually an x plus 5. No, sorry, it is an x minus 5. This is an x minus 5 times x minus 2. It's important to put the multiplication of that in parentheses because this minus sign in between has to distribute. A lot of students miss that and end up messing up the problem. So be careful to put parentheses when you need to include something or distribute something through later. So that negative sign gets distributed, which then cancels the 10s out, and you end up with a negative x squared plus 7x. I like to put the positive term first instead of putting negative x squared plus 7x. Doesn't really matter, but I prefer to put the positive first. So 7x minus x squared over, and you can multiply the bottom together, or you can leave it separate. Doesn't really matter either, and you get 2x minus 4 for that. Moving on, we get to transformations. So in the transformations, here we see the first one is describing the transformation of triangle A onto triangle B. Now there's only four types of transformations that you learn. One is translation. Translation is just shifting it somewhere. Well, obviously you can't just shift it without turning it. So that's not a translation. You also have reflection. Reflection flips it over an axis somewhere. Well, this doesn't flip it either. So the third one is rotation, and rotation will maintain the same size. The fourth one is enlargement, which either makes it bigger or smaller. Well, A and B are the same size, so it can't be enlargement. So this has to be a rotation. So you put rotation. Then you need to put how far it's rotated. It's rotated 90 degrees to the right, which would be clockwise. If it's 90 degrees to the left, you put counterclockwise or anti-clockwise. And so this is a 90 degrees clockwise with the clock. And then you need to put the center of rotation. The center of rotation is a little tricky on how to find it. Has to make, because it's a 90 degree, it has to make a 90 degree with the corner points. I chose these corner points, but you could also choose these. This one's a little harder because well, you could use this one. It still makes a 90 degree with this corner, or with this corner here would also be a 90 degree. Pick one of the corners, and you want to find a point that's 90 degrees between it. If you want to find it, you can also use lines. Draw lines between your points and find the perpendicular bisector. So if you draw lines between each of your corresponding points, and then find the perpendicular bisector of all of those, they will intersect at the center, which is 0, 0. Then they want us to do a few drawing of image. So find after a reflection in the x-axis. Well, here's the x-axis. So we're wanting to flip it over the x-axis. So if you flip this over the x-axis, what you do is you count how far it is from each vertex perpendicularly to your axis of reflection. Here's the x-axis, here's our vertex. You go down 1 to the x-axis, and then you go 1 on the other side, and there's your vertex there. From this vertex, you go down 1, 2, 3, 4. So then you go 4 on the other side, 1, 2, 3, 4. Over here, same thing, go down 1, 2, 3, 4, perpendicular to your axis of reflection. So 4 to the axis, 4 on the other side, you get your 3 points, draw your triangle. Then a translation, you're just following +7 on the x and -5 for the y value. So again, you start with your vertex, you go +7, 1, 2, 3, 4, 5, 6, 7, and then you go down 5, 1, 2, 3, 4, 5. There's your point, and you do that from each vertex, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5. And with this one here, over 7, down 5, and there's your 3 points, draw your triangle. The last one here is an enlargement. You recognize it from the matrix here. You have an enlargement of 0.5, and means you take 1/2 of your values for your x and y value. So your -4 now shrinks to -2. Notice this here represents your x. This is your x column. This is your y column. And this is the one in the first position, and this is in the second position. So meaning like your ordered pair. So your x, then your y. So half of your x and half of your y. So half of -4 is -2, and half of 1 is 1/2. Then this one is -4 also, so that would be -2, and 4 for the y would shrink down to 2, so -2, 2. And this one over here is at a -2 on the x, so divide by 2 is -1, and it's 4 on the y, divided by 2 is 2. So you just take half of your coordinates and you get this little triangle right here, and that's an enlargement by scale factor 1/2, and your origin is at this, or your center is at the origin. So that's how you do those. Now, whoa, this one's kind of blurry here. Wow, sorry, this is pretty blurry. You have a triangle with, you have a 4 and an x-1 in parentheses. Pretty hard to see, but this is a 4 times parentheses x-1. I just multiplied it together to give 4x-4. On the bottom, we have a 2x plus 5, I guess it is. 2x plus 5, really blurry there. Then it says the area of the triangle equals 30. So that's why area of a triangle is 1/2 base times height equals 30. So I just put in the parts. 1/2, the base is 2x plus 5. The height is 4x minus 4. The area is equal to 30. So I just multiplied the 2 from the 1/2 to the other side to give 60. Multiplied out my binomial, expanded the binomials here to get 8x squared plus 12x minus 20. Subtracted the 60 over to get a quadratic equation. And we have to show that it gives us 2x squared plus 3x minus 20. So to get that, we need to divide everything by 4, and that gives us our 2x squared plus 3x minus 20. Then in the next part, it says to factorize. Again, sorry, it says blurry. It says using factorization, solve the equation of 2x squared plus 3x minus 20. So the factors of 2 are 1 and 2. The factors of 20 are 1 and 20, 2 and 10. And we have to subtract to get a 3. So 2 times the 4 will give us 8. 1 times 5 is 5. And 8 minus the 5 gives us the 3. So we want the 8 to be positive. So the 2 from the front times the 4 from the back gives us a positive 8x. And then the 1 from the front and the 5 from the back gives us a negative 5x. So positive 8x minus 5x gives us the 3x. Then you solve each of these, set them equal to 0, and solve. So that gives us 5/2 and negative 4. Moving on, it wants us to calculate BC. BC is the hypotenuse. Well, this is a right triangle, so you're going to use Pythagorean theorem. So here we have this squared, or what I did was first you need to, let's get rid of the x. Let's get numbers here. So here were the two algebraic solutions, 5/2 and negative 4. Well, obviously x cannot be a length of negative 4. If you put negative 4 in, you're going to get a negative length. We can't have negative length. So this negative 4 gets thrown out. The proper x value for our practical situation is 5/2. So we plug 5/2 into our side and our height. So 2 times 5/2 plus 5 gives us a 10 for the base. Plugging 5/2 into the height gives us a 6 for the height. Now we can do the Pythagorean theorem, a squared plus b squared equals c squared, where the hypotenuse is the BC. 36 plus 100 is 136. Square root gives us 11.7 to 3 significant figures. Now we move, this is much more clear, better picture here. We move to this graphical solutions. So we need to plug in our negative 2 into the equation here. Be careful when you're plugging negatives into your calculator that you put them into parentheses so that your calculator follows the proper order of operations. So you put it in parentheses, you work it out, you get negative 3. You plug in the 3 into your equation and you get 17. So here's the working for that, negative 3 and 17. You take these points and you plot them on the graph, and you get this graph right here, the curve that goes up. Notice these will always be smooth curves, so you shouldn't have any jagged edges. They should be smooth curves that you have there. Then we move on to the second part. It says, draw a tangent that goes through 0, negative 17. Well, here's 0, negative 17. So a tangent means that your line does not go through the graph. Your line has to touch the graph, but not go through it. So you want to take a straight edge like a ruler, put it on this 0, negative 17, and just rotate your graph around so that you can see where it comes up and touches the graph without actually going through it. So you can't go this way because you would go through the graph. You can't go this way. You have to come off here to the side and slide it over until it just touches, and you'll see that it touches right about here. And so the place where it touches, my estimation was 2, 1, and it gives you a window of opportunity. You could say anything between 1.7 to 2.2, and then anything between -1 to 2.5 for the y value. So I gave the 0.21 where it touched on mine. Then it asks for the equation of the tangent. So the equation of the tangent is going to be y equals mx plus c, and we need to find slope. So we take our 2 points, 0, -17, and 2, 1, or whatever your point was for the 2, 1, and do your slope formula, y2 minus y1 over x2 minus x1. This is the value of m. I should have put m equals out here in front so it'd be clear, but we're solving for m. M equals y2 minus y1 over x2 minus x1 gives us 18 over 2, which is 9. So y equals 9x. Now, you could plug in one of these points into x and y and solve for the -17, but we already know that it's -17 because the plus c stands for the y-intercept, and so it's crossing the y-axis at the -17. So you can save yourself a little bit of time if you recognize that that -17 is the y-intercept. But if you don't recognize that, then you can use the 2, 1, plug it in, and you would have 18 minus 1 is -17. So by drawing a suitable straight line, solve the equation y cubed minus 6x minus 3 equals 0. A lot of students try to do this by plotting a bunch of points or by solving it algebraically, and it takes a lot of time. You don't have to do that. What this wants you to do is to start with your original x cubed minus 3x minus 1, and it wants you to see what is different. So we want this x cubed minus 3x minus 1. X cubed is already the same. We want -6x to change to -3x. So we need to add 3x to both sides. We want our -3 to change to -1. So we need to add 2 to both sides. So on the left, you have your original graph. And then on the right, we have our suitable straight line in the form of y equals 3x plus 2. So what we're doing is splitting these into two separate graphs. So the solution of x cubed minus 6x minus 3 equals 0 will be where these two separate lines, or this curve and this line, intersect. So 3x plus 2, we come back to our graph, we put plus 2 as the y-intercept, the 3 is the slope, so count up 3 over 1. Make sure you're paying attention to the scale. It's not 3 boxes over 1 box, it's 3 units. So this is 2, and up 3 on the y-axis scale over 1 is all the way over here to the 1 on the x-axis scale. So this is actually up 3 over 1. You draw your line through that, and notice it crosses at 3 different locations, which are the 3 answers that you get right here. So on my graph, it crosses right here. So you go up to the x, you find the x. You might want to use a straight edge to find that. Here's the x value. And then here's one right here. Find that x value. And the other one is way over here, right there. Find that x value. So on mine, I have these 3 values right here, -2.1, a -2, or a -0.55, and 2.65. So again, they give you a window of possible values that you could choose from. It doesn't have to be exact, but it does have to be close. So mine was right on the edge of this window. I'm right in close to this side here and kind of close to this side on this one, but I'm within the acceptable bounds for all 3 values, and that's how you do this. Note this is graphical solutions. Most of the time you will not be solving these algebraically. You'll be splitting them apart into one graph that you've already graphed and another graph that you should have already learned, like a straight line that you can then graph yourself and find where they intersect. Moving on, we get to a speed time graph. So here says find the acceleration for the runner. Remember that acceleration on a speed time graph is slope. When you multiply speed or speed divided by time, you get acceleration. Your meters per second divided by second gives you meters per second squared. So we want to take the slope, so the change in the y-axis, 3 minus 1.2, divided by the change in the x-axis, 3 minus 0, gives us 1.8 over 3, which is 0.6. So the acceleration is 0.6 meters per second squared. Then total distance, remember distance under a speed time graph is area, or area, the area under the speed time graph gives you distance. So this one's the area for the runner. So the area for the runner is over here. We have 1/2 of 1.2 plus 3. So the runner includes all this area, not just the area between the runner and the walker, but all the area between the runner and the x-axis. So here, this is a trapezoid. So that's why I have 1/2 the two bases, which is 1.2 and 3, and then the height is the 3. So 1/2, add the two bases together, times the height gives you 6.3. Then in the middle, we have a big rectangle. So we have 15 minus 3 times the height, which is 3. So 15 minus 3 is 12. That's the length times the height is 3. That gives us 36. And then on the right, we have another trapezoid, or trapezium, if you call it trapezium. So again, we have 1/2, add the two bases times the height. The height is this way. So we get 1/2. The two bases are 3 and 1.2. The height is 4. 19 minus 15 is 4. You get 8.4. Add those three together, and you get 50.7 for the area. Moving on, how far is the runner ahead of the walker? Notice that when the walker starts, they're on the same path, but at t equals 0, that is when the walker starts, the runner is 10 meters behind. So we got to keep in mind that the runner starts 10 meters behind the walker. So let's find the distance of the walker. So this is walker's distance, and the walker's distance is simple. To get distance, you multiply speed times time. Speed times time is distance. So the speed is 1.2 times a time of 19. So 1.2 times 19 means the walker will have walked 22.8 meters. For the distance of the runner, we already found that right here. So don't forget to look at your previous work, because a lot of times IGCSE questions are linked. This is a linked question. So you don't have to go back and repeat all this work. You should recognize you already found the distance of the runner. So it's 50.7, but we need to subtract 10 because the runner is 10 meters behind the walker. So that means that we subtract 10 to put them at the same starting point, and then the runner is 40.7 meters. And then how far is the runner ahead at the end of the 19 seconds? You subtract the two, so the runner is ahead by 17.9 meters. So be careful on that. 10 meters behind, you have to subtract the 10 meters from the runner. Okay, moving on, we get to geometric properties of circles. Here we have angles. So it gives us the center is at the origin, and we have EA is tangent to the circle at A, and we have these other two angles given. Well, when you have a tangent to a circle, it will be 90 degrees at the radius. Here's the radius because it's coming from the origin to the point of tangency. That means this is a 90-degree angle. So if we take this 90, actually, this 90 goes to right here, not over to here, to right here. So this 90 minus the 61 gives us 29 for right here. And then that's what it's asking for. Find the angle BAO. So BAO is this angle right here. So that's the 90 minus 61 is 29. Then find angle AOC. Find A is right here, OC, AOC. So if we take 55, which is this angle here, minus the 29, that gives us 26. I didn't write it in, but this right here is 26. If we have 26 here, it means this one over here is also 26 because these are the same lengths. So they're both radius. These are the same lengths, means the angles here are also the same. So we have 26 times 2 is 52. Subtract that from 180 because your triangle adds up to 180. So 180 minus the 52 gives you the 128 for your AOC. So that's 128. Then we want to find angle ABC. ABC is ABC. Well, 128 is the central angle. And ABC is the inscribed angle, and the inscribed angle is half the central angle. So here we go. 128 is the central angle divided by 2 is 64. 64 is the inscribed angle, meaning it's written on the inside of the circle. Last one here, find angle CDA. CDA is this one over here. So angle CDA. Notice CDA is an inscribed angle going the opposite of the central angle 128. So if we take 360 minus the central angle of 128, that leaves us with 232 for the other central angle, because this has to be 360 degrees. So 360 minus the 128 gives 232. Again, that's a central angle, and angle D opens up to the same arc place locations as our 232, but this is inscribed, so we got to divide that by 2 to get 116. Okay, going on here to page 12, we have this bearings problem. So we have Geneva, Budapest, and Hamburg. Here's Geneva, letter G, Budapest, B, and Hamburg, G or H, letter H. So a plane flies from Geneva to Hamburg. That's from here to here. It's 864 kilometers. The flight takes 2 hours and 20 minutes. Calculate the average speed in kilometers per hour. Remember that minutes is not out of 100. Minutes is out of 60. So this would be 2 hours and 20 out of 60 minutes is 2 1/3 hours. As a fraction, that's 6 7/3 as a improper fraction. So 864 divided by 7/3 is 370.29. To 3 significant figures is just 370 kilometers per hour. Then it says to use the cosine rule to calculate the distance from Geneva to Budapest. Remember, the cosine rule is when you have a triangle that does not have a right angle and you do not have a pair of side and angle. Notice we have the side but not the angle. We have this side but not the angle. And we have this angle but not the side. So that's when you use the cosine rule. Otherwise, you'd use the sine rule if you had a side and its angle as a pair. So cosine rule is c squared. Well, I like to use little c squared equals a squared plus b squared minus 2ab cosine capital C being the angle. So this is the side opposite the angle, and the AB are just the other two sides that you have. So the other two sides are the 864 and the 928, and the C, the little c that we're finding is this one here, and the big C that goes with the cosine is the 67. So when you put those numbers in, here you have GB squared equals 864 squared plus 928 squared minus 2, 864, 928 cosine 67. You square those out, you multiply this out. Now be careful right here. A lot of students make this mistake of subtracting these two numbers right here. You cannot do that because this is multiplication. Multiplication comes before subtraction. This is a matter of order of operations. A lot of students make that mistake and they subtract first. You can't do that. So you need to multiply this by cosine of 67. Also make sure your calculator is in the degree mode, not the radian mode. So just check your calculator before you do that. Multiply this out. Then you can subtract. Then you can square root both sides to get the GB by itself. And you get 991 to 3 significant figures. The 5 rounds up that 0 to a 1. Page 13, the bearing from Budapest to Hamburg is 133. Now remember, bearing starts from due north. It's different from trigonometry. Trigonometry starts with the 0 on the right-hand side and goes counterclockwise. With bearings, you start at north and you go clockwise. So the bearing from Hamburg to Budapest is a bearing of 133. Starting at north, you rotate clockwise until you're facing Budapest, and that's 133. Now what it wants is what is the bearing from Budapest. So you go facing north and you go around clockwise until you are facing Hamburg. So you don't go this direction, you go from north clockwise all the way around until you're facing Hamburg. So we need to go from here all the way over to here. Well, if this is 133, then this, notice I make my little axes here. So this would be 90 degrees. So 133 minus the 90 gives us 43. And this x-axis would be parallel to this x-axis. So alternate interior angles are equal, meaning this angle is equal to this angle right here, only to the x-axis, not between here and here, but only to the x-axis. So this goes all the way around from the y-axis to the x-axis to the negative y-axis to the negative x-axis, and then 43 more. So that would be a total of 270 degrees plus 43 gives the 313. Now we need to calculate the bearing from Budapest to Geneva. The bearing from Budapest to Geneva is a little bit trickier here. So let's see what we got here. The bearing, of Budapest from Geneva. So from Geneva, going north until Budapest would be this here. So from Geneva, here's your north, until Budapest would be to this line right here. So we need to find this one. Well, it would help us if we knew this angle here. And this is a difficult angle because notice these two little slivers here that we don't know. We can figure this one out because this is a 90 here. And actually, if we take this 90 minus the 43 that we found over here gives us 47. And then if we take our 67 minus 47, that will give us the 20 here. And this 20, because this y-axis is parallel to this y-axis, alternate interior angles are equal. So you can work from this 43, subtract 90 gives you 47, 67 minus 47 gives you 20. alternate interior angles are equal gives you this 20 down here. That gives you this little piece out here, but we still don't know this piece in here. So we can use the law of sines because we do have a pair now that we found this 990.51. We found the pair. So we can use the law of sines. Notice I did not just use the 990. You want to use more than 3 significant figures so that your final answer is correct to 3 significant figures. So I use 990.51 over sine of 67 equals 928 over sine of G, which is our, what is that name of that town? Geneva. And so you solve for sine of G, multiply it up here, multiply it up here, multiply your sine 67 over. It's just like cross multiplying. So cross multiply and then divide by the 990.51. So you can look at the math here, but basically just cross multiply, solve for sine G, and then don't forget to inverse sine. All of this, you can do it in your calculator all at once, and you get 59.59. 59.59 is this angle in here. And then we need to add the 20 degrees because we have to start from due north, and that gives us 79.6. Now, actually, if you're writing this as bearings, you're supposed to write it with 3 numbers in the front. So technically, it should be 079.6, but they will accept 79.6. But because you are using bearings, you're supposed to have 3-digit numbers. So it should be 079 and then 0.6. So moving on, oh, this one's blurry as well. Kind of hard to see, sorry about that. This is blurry, I didn't realize this is blurry. We have a total of 120. It says use the midpoints to estimate the average here. So the mean average. So here's the midpoint estimate of the, can't really tell what it says, but I think it says the mean average. So to find the mean average, you first have to take the midpoints of these. To find the midpoint, you just add the 2 numbers and divide by 2. Don't overthink it. Some students accidentally, they try to do it in their head and they get the wrong values. Take your calculator, add the 2 numbers, divide by 2. 30 plus 10 is 40, divide by 2 is 20. 40 plus 30 is 70, divide by 2 is 35. Just do that and you'll get, here's the midpoint. So what you want to do is you want to multiply the frequency, which is this column right here, times the midpoint. So that will give you 16 times the 20 plus the 18 times the 35. And you go through frequency times midpoint all the way through and then divide that entire, add all that up first. I should have put it in brackets to make it more technically correct. And you get 5,135. All of that divided by 120. This is a 120 here. And that gives you 42.79 or 42.8 to 3 significant figures. Complete the histogram. Well, to get histogram, you need frequency density. And to use frequency density, you need the class width. So class width is just subtracting the 2 numbers. Here's 30 minus 10 is 20, 40 minus 30 is 10, 45 minus 40 is 5. So go through, calculate your class width. So frequency density is the frequency divided by the class width. So 16 divided by 20 is 0.8, 18 divided by 10 is 1.8, and so on. Frequency divided by class width gives you frequency density. Frequency density will be your height that you make your histogram. Make sure the base is connected. There should be no gaps. Histograms are continuous data, so this is not a bar graph. There are no gaps between it. Make sure that your lines connect there between the bars. And then the heights are your frequency density, and you just make it fit your scale that they've already provided on the side. And I like to put the frequency density at the top so that the person looking at it doesn't have to guess, like this 2.1, they don't have to try to guess where that line is at. You telling them right there. If you get them to look at it, then and they're kind of picky, they might take a point off. If you put the numbers on top and it looks right, they'll accept it. So then here, now this is a lot more clear. They just ask you to compare the two histograms between Saturday, which was this one up here, and Wednesday. And if you look at the values, this one goes all the way up to the 70. And even right here, this is really high at the 50 mark, where this one is starting at the 60s. At the 50, it's not very high, and it's sort of high at the 40 mark, but not as high as the 8. And so what you should basically get between this is that there are, on average, less shoppers on Wednesday than on Saturday. This is only 1 point, so don't spend too much time thinking. You only need one statement that compares the two, so don't spend a lot of time here. It's only 1 point. Just do it quickly and move on. Now we get to this lot of units here. So the area is 55 hectares. The rate is 75,000 liters per second. It wants you to show that 90 million liters will flow out in 20 minutes. Well, this is in liters per second. So you have 75,000 liters per second. We need to convert to minutes, so 60 seconds per minute, and then we're going for 20 minutes. So again, line up your units, the seconds cancel, the minutes cancel, that leaves you with 90 million liters. Now we have a quite difficult question here where you're dealing with a volume and you want to show that the water has dropped, or calculate how far it has dropped after the gates have been open for 20 minutes. So what I did is I start with area because it gives us hectares, which is area. Volume is just area times height. So we take our 55 hectares and we need to convert it to centimeters cubed because it wants the answers in centimeters. So we take 55 hectares multiplied by 10 to the 4th power to change it to meters squared. So that's this conversion right here. 1 hectare is 10 to the 4th power. Then changing it from meters to centimeters. 1 meter is 100 centimeters, and we're squaring it to match the square here. And that gives us 5,500,000,000 centimeters squared. And then I take the liters here, 1,000 liters for 1 meter cubed, and I convert it from liquid volume to linear volume. And so the 90 million liters divided by 1,000 liters, and then convert that from meters to centimeters gives us this really big number, 9 times 10 to the 10th centimeters cubed. And then to get volume divided by area will give you the distance in drop. Because this is 3-dimension divided by 2-dimension gives you 1 dimension. And so the 9 times 10 to the 10th divided the 5.5 times 10 to the 9th equals 16.36. We're already in centimeters. And then in 3 significant figures, 16.4 centimeters. There's probably other ways that you could do it, but this is the way I chose to do it. I chose to do volume divided by area to get the linear. Now here we are, we have our arc length and sector area. And so it wants us to find the perimeter of this sector. So the perimeter is adding up all the way around it. So we have 8.5 plus the arc length plus 8.5 again. So arc length is a part of a fraction of the circumference. So we want 76 degrees out of a complete circle, which is 360, times the complete circumference, which is 2 pi r, the r being 8.5. So we have the fraction of our circle times the circumference of the circle gives 11.27. That's the arc length, which is represented by S. Then we have 8.5 on both sides. Add those together to get 28.3 to three significant figures. Moving down to page 17, here we have volume, 1/3 pi r squared h. So 1/3 pi r is the 10, height is 36, and you just multiply it out, 3,770. You're just following the formula. Now the cone is cut parallel to the base, and so we need to read carefully. It says the volume of the smaller cone, that's this cone right here, is half of the original. So I take the 3,770 or the 3,769.9 and divide it by 2 to get 1,884.96. And then it says, you got to read through this. The smaller cone is melted down into two spheres. These two spheres have a radius ratio of 1 to 2, but we're dealing with volume. So if your radius is linear, if your linear ratio is 1 to 2, then that means the volume ratio is 1 to 8. Linear to volume is cubic. So you cube the linear ratio. 1 cubed is 1, 2 cubed is 8. So the volume ratio will be 1 to 8, meaning that the total parts are 9. And so the small cone, it wants the smaller sphere, the smaller sphere made from the small cone will have 1 out of these 9 parts because it's 1 to 8. The smaller sphere would be 1 out of a total of 9 parts. So we need to divide that volume by 9, which gives 209.44. That then is the volume of our smaller sphere. We can then plug in and solve for the radius. Here's the formula, 4/3 pi r cubed. Divide by 4/3 pi, and that does come out to 50. And then you cube root, and you get your 3.86 to three significant figures. Here we have a little bit of matrix, which is not on the new syllabus, but this is quite easy to do. Just 3 times matrix A minus 2 times matrix B. 3 times these numbers, it just distributes a scalar value, distributes through your matrix, and then distribute this one through, and then subtract. You just subtract their relative locations, and you get -19 and -2. So -9 minus 10 and 6 minus 8. Then this here is the symbol for the magnitude of vector A, which has this column vector here, -3, 2. So the magnitude is simply squaring the components. It's like the Pythagorean theorem. So -3 squared plus the 2 squared, and then you square root it. And magnitude is the same thing as the distance of the hypotenuse, which then gives you 9 and 4, which is 13. Square root of 13 is 3.06. And 3.06 to three significant figures. This 6 rounds up the 0 to 1, so you get 3.61. Now down here, it wants you to find m and n using 2 simultaneous equations. So we have a, b, and c. We just use those column vectors with the m and n, and you multiply it through the x part and then also through the y part. So you get a -3m plus 5n equals 14. Here's our a, b, and c plugged in to the locations they give in the formula. And then you do the y component part. So 2m plus 4n equals 9. Now you have simultaneous equations, which you should be able to follow through. I multiplied by 2 and 3 to give a common coefficient of 6. And then I added the 2 equations together to eliminate the m's. That left n, solve for n, plug it back into either one of the equations to solve for m. And so you can stop at that and look at the math on how that happens there. And you get -1/2 and 5/2. Now on to page 19, we have vectors. And here we have this diagram. So notice that C is the midpoint, and this vector C only goes from O to C. So if C is the midpoint, then that means from C to B is also a little C vector. Then it says AB to, or sorry, AD to DB is a ratio of 3 to 5. So AD is 3, DB is 5. That means there is a total of 8 pieces on this entire length here. So in a ratio of 3 to 5. So I put the total there of 8. There's also a ratio of OA to AE of 2 to 3. But in this case, A is not the total length, so I don't put a total. And you could put a total of 5, but in this case, the A is a smaller piece here. It's not a total length. So this A has 2 parts to it. So each part then, if the total length is A, then that means each of the 2 parts has to be half A. Half A and half A make, those 2 parts make a full A. So when you're doing it, instead of going from small to bigger, we're going from bigger to smaller, then you have to divide it. So A divided by 2 gives us half A for each part. This has 3 of those parts, so half A times 3 then gives you 3/2 A for the A to E. So it works a little differently than this one here. So we want A to B. A to B is this. So A to B first is OA to get you to A. Remember, everything has to be from the origin. So first we have to start from O, go to A. And OA is connecting OB, which is this one here. So notice our vectors are tail to tail. So that means we need to subtract OA minus OB. So A to B is going this direction. Here's the end where we end up, minus the start. We're starting at A, ending at B, end minus start. So OB minus OA. So that gives us 2 C's minus an A. 2C minus A is the answer. Now it wants A to D. A to D is this little section. It is 3 out of 8 pieces. So all you have to do is take 3/8 of your answer here. 3 out of 8 pieces of 2C minus A gives you 3/4 C minus 3/8 A, which is this here. Now C to E. C to E is from here all the way out to here. So we want to go from OC and then minus, we can't go directly here because we don't know these yet. So we want OC and then O to E. So if we're going C to E, end minus start, so OE minus OC, OE minus OC. OE is our 2 parts and 3 parts here. This is half A and half A make 1 A, and then from here to here is 3/2 A. So what we're adding is the A and the 3/2 A. Okay. So A and 3/2 A is 5/2 A minus the C, which is this one right here, and that gives us 5/2 A minus C. So it's a little tricky breaking these ratios apart, especially it's easier when you're going small to big, but when you're going from the parts down to smaller parts, you have to divide it and then calculate these small parts based on the ratio. C to D. C to D is only going from here to here. So C to D would be going from C down to O, over to A, and then up to D. I think that's what I put. Or C to D would be OD minus OC. You could put it that way. I think that's what I put. OA plus AD, OA plus AD. This is the end of this vector here. End minus start is OC. So end minus start. Here's the end minus the start. So OA was A. AD is right here. Here's AD. 3/4 C minus 3/8 A. Again, look to see if you've already done some of the work. All of this minus the C. So we just combine like terms. A would be 8/8 minus 3/8 is 5/8 A. 3/4 minus 4/4 would give us a negative 1/4 C. So a whole one would be 4/4. 3/4 minus 4/4 is a negative 1/4. Then it wants us to find this proportionality constant, CE to CE, what proportion of that is to CD. So the CE, what is the constant multiplied by CE to give us this CD, or CD is what proportion of the CE? So we have CE equals the proportionality of CD. So if you solve for K, you get CE over CD. Here is CE, here is CD. You've already done the work. You divide it. Now, the tricky part is you want to get the same factor so that it can cancel out. So when you look at these numbers, what you want to do is what can you factor out of this denominator so that the denominator has a factor the same as the numerator so you can cancel it out. And so if you take out this is the easy part here. If you look at C and 1/4 C, divide out the 1/4. When you divide out the 1/4 from 5/8, you get 5/2. Looks complicated, just use your calculator and it will do it for you. I'll give you 5/2. So 5/8 divided by 1/4 is 5/2. Now this top one I should have put in parentheses is the same as the bottom one, so it cancels, leaving you 1 divided by 1/4. Invert and multiply leaves you 4. So the value of K is 4. Moving on to our last page, page 20 is probability. So we have 3 sets of packets, barbecue, salt, and chicken, 20 packets total of potato chips. So Maria takes 2 packets without replacement, show that they are both salt flavored is 9/38. Well, there are 10 salt and there are 20 total packets. But if she takes it out and doesn't replace it, now there's only 9 salt and there's only 19 total. So that leaves you 90 over 380, which reduces to 9/38. So don't forget to reduce the category that you drew from, as well as reduce the total both by 1. So 10 reduces to 9 and the 20 reduces to 19. And so they're both salt and gives us your 9/38. Then find the probability that she takes 2 packets of different flavors. Well, you got different ways of getting 2 flavors by drawing twice. You can have barbecue salt, barbecue, what's that third one? Chicken, salt barbecue, salt chicken, or chicken barbecue and chicken salt. Now, notice that the barbecue salt and the salt barbecue are the same thing, but backwards. So you have to multiply by 2. And the barbecue chicken and chicken barbecue are the same thing. And salt barbecue and, or this third one, salt chicken and chicken salt are the same. So you only have to figure out those and then multiply them by 2. So if you have barbecue salt, there's 6 out of 20. Then don't forget, now your salt is 10 out of 19. Your next one is barbecue chicken, so 6, and then chicken is 4, 6 then 4. And then of course the total goes down by 1, 20, 19. Then on the last one you have your salt chicken. So there's 10 salt and 4 chickens, 10 and 4, but because you don't put it back, the total reduces to 19. So because you're taking from 10 different categories, the top number doesn't reduce because they were from different categories, but the total did reduce because it was without replacement. You multiplied by 2 because there were like sets. Add those up, 6 19ths, 12 95ths, 4 19ths, gives you a total of 62 95ths. Then here at the very end, Maria takes 3 packets without replacements. Find the probability that she takes at least 2 packets. There's a couple of ways of doing this. This is the way that I did it. Like I said, there's more than one way to do it. But if there's at least 2 packets, it means there can be 2 or more. So if there's or more, that means all of them could be chicken. That gives you 3 packets of chicken, 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 chicken. Or if it's at least 2 packets, it can be a chicken, chicken, and not chicken. You don't have to worry about the barbecue and salt. Just call it not chicken. So chicken, chicken, not chicken, or the not could be drawn in the second position, or the not could be drawn in the first position, because you have 3 draws here. So you need to allow for that not chicken to be drawn in 3 different locations, first, second, or third position. So that gives us 3 different pathways, but notice it's a chicken and not. So the bottom numbers are going to go from 20 down to 19 down to 18 because you're drawing without replacement. And then you have a chicken, another chicken, so the 4 reduces to 3, and then the not chicken will always be 16 because you have 10 salts and 6 barbecue. So that 1 not chicken is going to draw from 16 packages out of a total of 18, or the 16 will be one of the top numbers. Your 20, 19, and 18 will be the bottom numbers no matter which way you do this. You're going to have a 4, 3, and 16 on top, and a 20, 19, and 18 on the bottom. They might be in different orders, but it will be the same combination. Times 3 gives you 8 95ths, plus the 1 over 285 gives you 5 57ths. So there we have a quick fix going through our winter 42 2018. I hope this helps. Again, focus on training your mind so that you can get that strategy down as you do these practice test sets so that you can start getting them right and improve your quality as you continue. So thank you for listening, and see you again next time. Thank you for joining.